In this circuit, we are supposed to find the input resistance of this circuit. Now, the basic procedure to find input resistance of any circuit is if we have two terminals like this, across which we have to find the input resistance Rn, we what do we do is connect a voltage source Vn. You can either take a numerical value like 1 volt, 2 volt, something, and find the value for the current also, or you can just name it Vn and uh, start solving with the variable itself. So we have voltage source Vn. We put a voltage source across the terminal Vn, and uh, through solving the circuit we find the current which is flowing through the circuit, and let's label it In. And to find the input resistance through this uh, two terminals, across these two terminals, what we do is V equals IR, hence R equals V over I, which means the input resistance is equals the Vin over In. And this is how we generally find, or this is the general procedure for finding an input resistance for any circuit. This procedure you might recall it from finding Thevenin's resistance, Thevenin's voltage, and this is similar. This is that only, but just a different name. So uh, also, the circuit is a bit unusual. You generally don't get to see this 3R resistor, and whatever the circuit without the 3R resistor is a simple non-inverting inverting amplifier. And we will see what is the role of this 3R resistor, and it will be very interesting to see results on how the parameters change when we change this 3R resistor. So let's just start by solving the circuit. So we need to find the input resistance across this terminal, hence we are connecting a voltage source Vin and grounding it. We also need to find the total current flowing through it, In. And obviously I'm just predicting, analyzing the circuit. We can see that the input is being applied to the inverting terminal, hence the output will be in the negative side, in some negative something, some so the output V naught will be some gain, some negative gain into Vin. And with this basic analysis I can say that the current will flow through the voltage source which I have put in, rather than flowing out of into the voltage source. And if the same would have been through the non-inverting terminal, the circuit would, the output voltage would have been greater, and the current will be flowing into the voltage source. So the In will be splitted into these two parts, I1 and I2. So the total input current is I1 plus I2. Let's keep it aside and start solving the circuit. Um, if we see here, by applying the golden rule for op amps, we are considering an ideal op amp. The non-inverting terminal is at ground potential, and so hence the inverting terminal will also be virtually grounded. And applying see the current flowing through the resistor R will be the same current flowing through this resistor 2R, because no current will be flowing into the inverting terminal. So applying that logic, you can the current flowing through the resistor R will be Vin minus the potential here is 0 upon R, which is will be equal to the current flowing through this. Here the voltage is 0, here it is V naught, hence we write 0 minus V naught upon 2R, and hence we get V naught equals negative 2 times V in. And it perfectly matches our analysis of like we predicted previously, that V naught will be some negative gain into the input voltage, and it perfectly matches it. Now that we have got the gain, You might be also thinking that doesn't this 3R resistor contribute to some change in the gain? Well, actually no. If you see the circuit carefully, you will see that this 3R resistor is not feeding back into the terminals itself of the op amp. It is actually feeding back to the voltage source, and hence there will be no gain, that will be like the gain will not be affected with the resistor 3R. So now it's time to calculate the input current. As mentioned above, the input current will constitute of two separate currents, I1 and I2. Uh, to find I1, it will be flowing through 3R resistor. So Vn minus V0 upon 3R, which will be Vn minus C. Also, because we are finding our input resistance, we need to find the current input current in terms of Vn. So hence I am using this relation to change everything in terms of Vn. So V0 will be written as minus 2 times Vn upon 3R, which we will get as Vn upon R. Similarly, to calculate I2, uh, I2 will be V in minus 0 upon R, which is V in upon R. So the total current I in will be I1 plus I2, which means 2 V in upon R, and from here we get V in upon I in, which is the input resistance, which is also equals to Thevenin's resistance, which is equals to R upon 2. So the input resistance came out to be R upon 2. Now that we have analyzed this circuit, let's do some changes and analyze this circuit also. So for simplicity, I have already solved it. Um so the only difference that is there in this circuit is the 3R resistor. So I've changed it from 3R to just R, and after following the same procedure, we see that the input resistance has actually decreased, and the next logical step would be completely removing it. But if we completely remove it, the input resistance is actually R. So we see that trend of, see, initially we had 3R, then after decreasing it, the input resistance also decreased. But if we completely remove it, the resistance will the input resistance will actually increase. So why are we doing it? See, op amps are amplifiers, so amplifiers need to be cascaded to get a higher gain while being stable. So we use negative feedback to make the op amp stable, and to get a higher gain, we cascade stages of op amps uh, so that we get a higher gain. And hence the input resistance is very crucial to know how much loading effect does the op amp has on the previous stage of the total amplifier. We have cascaded stages, so we have number of stages, like stage here we have an op amp, the output is being fed to another stage of the op amp. See, we have input here, so this input might be the output of some similar stage like this. The V out might be feeding into some uh, another op amp network. So we need to find the input resistance as to how the op amp, the voltage is being uh, loaded. So the see, let me just make here. So it's similar to this: V in, some input resistance Rn, and the total load resistance RL. So lower the input resistance, better is the voltage, higher is the power transfer to the RL. So better is the voltage regulation also. So if Vin is lesser, uh, lesser Vin is better in this case, and we would obviously, if we see this problem through the in perspective from a designer perspective of view, we uh, we would want to minimize R as low as possible, but not completely remove it. So ideally we would want short circuit, and if we completely remove it, it will the maximum input resistance will be R. And I hope you got some insight about how this 3R resistor, the total input resistance part is there. Although it is not contributing into the gain, in all the three cases, you see that the input, the gain is -2. So there is no change in the gain, but it just changes the input resistance, which will be helpful in multiple stages of these kind of networks. Thank you and happy learning.